Welcome, dear students. Today we are going to discuss the very important topic of organic chemistry, class 11th, that is conformation. What is conformation? As you know, saturated hydrocarbons and unsaturated hydrocarbons differ from each other on the basis of number of bonds present between a carbon and carbon. In case of saturated hydrocarbons, there is single bond present between a carbon and carbon. In case of unsaturated hydrocarbons, there may be a double bond or a triple bond. Now, in case of saturated hydrocarbons, as there is single bond present between the carbon and carbon, due to this single bond, these compounds can be rotated, and we get an infinite number of momentary arrangements of atoms in space. This infinite number of momentary arrangements of an atom in space is called as conformation. So let's explain what is this. First, you have to remember that infinite number of momentary arrangements of atoms in space is called as conformation. Now let's explain. For example, we are going to discuss the conformation of butane. Let's take the example of butane. Very important topic. And this conformation is related to the stereochemistry. That is the arrangement of atoms in a three-dimensional space. Separate branch of chemistry, that is stereochemistry. Now butane. Butane is like this: CH3. This is hydrogen. This is hydrogen. This is hydrogen, and this is CH3. So this is butane. Number of carbons 1, 2, 3, 4. Now, to explain the rotation, that is number of momentary arrangements, we have to write the Newman's projection formula to explain the rotation of this butane. So how to write the Newman's projection formula? Suppose the compound is like this and we are watching the compound from this side. So this is our eye. We are watching this carbon. So it is just like this. This is the carbon and this is the another carbon. Now this carbon contains three parts. This is, for example, hydrogen, and this thumb indicates the CH3. This is the another carbon which is behind this first carbon. It also contains two hydrogens and a methyl group, that is CH3. So it is just like this. It appears like this. This is, for example, a carbon, and it has hydrogen, and a methyl group, CH3. Another carbon, which is behind this. We cannot see this carbon, but we can only see these two groups attached to that carbon. So we will represent it like this. This is another carbon behind this first carbon. So there is another hydrogen, there is CH3, there is H. So situation is like this. For example, this is a carbon and this is the methyl group. This is the another carbon and this is the methyl group. So two methyl groups are lying one behind each other. So this methyl group and this methyl group, they are behind each other. So I represent like this. This methyl group is behind this methyl group, and this hydrogen is behind this hydrogen. This hydrogen is behind this hydrogen. This formula is called as Newman's projection formula. Newman's projection formula. Newman's projection formula. Now what we have to explain? We have to explain the conformation, that is infinite number of momentary arrangements. So how will we do this? We are going to rotate it by, for example, 60 degree. Rotating it 60 degree, what happens? Keeping the one carbon fixed, for example, this carbon is fixed. This first carbon is fixed and the three groups which are attached to it are fixed, and we are rotating the second carbon like this. This hydrogen was, this methyl groups, they were opposite behind each other. Now on rotating this, it comes in the another direction like this. We say this is fixed. For example, this hydrogen is fixed, this hydrogen is fixed, this methyl group is fixed. The second carbon which lies behind this first carbon are rotating that carbon. So methyl group comes, hydrogen comes here, methyl group comes here, and this hydrogen comes here. So rotating the molecule leads to the formation of this structure. So these are the two structures. And if we further rotate this structure, 60 degree, so it becomes like this, keeping the first carbon fixed like this. This is CH3, this is H, this is H, and rotating the second carbon, what happens? This hydrogen comes now there, and this methyl group comes there, and this hydrogen comes there. Similarly, we can rotate it more 60 degree. So on every rotation, we get different structures. That's why we say infinite structures of a compound are formed when we rotate it. These structures formed are called as conformers, and the process is called as conformation. Now, what is the logic behind this? This is, for example, the first structure. Now, what happens in this first structure? Two methyl are close to each other, two methyl are close to each other, two hydrogens are close to each other. Now, here the repulsion between the hydrogen is maximum, repulsion between the methyl groups is maximum, repulsion between the hydrogen is maximum. So when the repulsion is maximum, that means this very compound has the maximum energy. So this is very unstable. This is very unstable. This is very unstable. And this structure is called as eclipsed or fully eclipsed. Fully eclipsed. So this is eclipsed. As you might be aware about the eclipse of the moon, when the moon, earth and sun come in the same direction. That's called as the eclipse. Similarly, methyl and methyl, they are one behind each other. Hydrogen and hydrogen, one behind each other. This hydrogen and hydrogen, one behind each other. So this is called as eclipsed form. So this is a fully eclipsed form, rather we can say. Now what happens here? The methyl and methyl are not opposite to each other. So this structure in chemistry is called as gauge structure. This is gauge structure. The energy of this compound is less than this compound. So if this is unstable, this is stable. This is stable. Now on rotating further this, we get another structure. This is also eclipsed but not fully eclipsed. So this is only eclipsed. This is eclipsed form. Why it is only eclipsed, not fully eclipsed? Because methyl and hydrogen are one behind each other. Not two bulky groups are each other. यहाँ पे क्या है, मिथाइल और मिथाइल एक दूसरे के पीछे नहीं है, रिपल्शन कम हो रही है हाइड्रोजन और मिथाइल के दरमियान. एज कंपेयर टू दिस, जब मिथाइल और मिथाइल ग्रुप एक दूसरे के नजदीक आ जाए तो रिपल्शन इज हाई एंड एनर्जी इज 0.9. Whereas in case of hydrogen, the energy due to repulsion is 0.7. So if this is having the high energy, this is having the low energy, this is having the least energy. We can similarly get another structure like this. For example, if we draw this, this is hydrogen, this is hydrogen, this is CH3. The structure may be like this. CH3 comes here, hydrogen comes here, and hydrogen comes here. Now see this very good compound. This is the conformation of this butane. What happens here? Methyl and methyl, they are opposite to each other. Hydrogen and hydrogen, they are opposite to each other. Hydrogen and hydrogen, they are opposite to each other. Means interaction between the groups is very, very, very much low. So this is very stable form, and this is called as the staggered. This is called as staggered. This is called as the staggered form. So conformation of butane shows how many structures. It shows first structure, that is fully eclipsed. Number second structure, that is gauge. Number third structure, that is eclipsed. Number fourth structure, that is stable, and this is called as staggered, fully staggered, or antiform. This is also called as antiform. Antiform. So butane on the rotation uses these structures. These structures and these structures are called as the conformers, and the process is called as the conformation. Now what happens in this conformation? If a compound is unstable in this very structure, why this is formed? If a compound is stable in this very structure, why not it remains only in this structure? Why it changed to this? Why it changed to this? Why it changed to this? This can be explained like this. If a person has 50 rupees in his pocket and he is going to some restaurant and he is offering for a tea, the cost of tea is labeled as 10 rupees, 20 rupees, 30 rupees, 50 rupees. He can offer 50 rupee tea cup, 20, 30 or 10 rupees because he has 50 rupees in his pocket. तो वो चाय 50 रुपए की भी पी सकता है, वो 30 रुपए की भी पी सकता है, 20 रुपए की भी पी सकता है, because he has 50 rupees in his pocket. So that is why these structures are possible. No doubt the most stable structure is like this. तो प्रेफर क्या करेगा एक बंदा, जब भी चाय पिएगा तो वो वाली चाय पिएगा जिसमें इसका पैसा कम ज्यादा हो. Same is the case here, but he is able. लेकिन वो क्या कर सकता है? वो 50 रुपए की भी चाय पी सकता है. तो हमें उस पे नहीं जाना है, हमें जाना है conformation. So what are the conformation? Rotation is possible in case of saturated hydrocarbons, and this leads to the formation of various structures. These are called as the conformers, and the process is called as the conformation. I hope you got this lecture. Conformation, you have to remember one thing, that is eclipsed, gauge, eclipsed and staggered. Which is the most stable? Most stable is staggered. Staggered is most stability. On the basis of stability, low energy. Which is the second? That is gauge. Which is the third? That is the eclipsed. Which is the fourth? That is fully eclipsed. Fully eclipsed. So this is called as the conformation. Thank you.